Welcome to Mrs. Neller's notes for her double block algebra class. These are the notes for section 13.3 entitled Finding Probabilities Using Combinations. And today we're going to use combinations to count possibilities, and that's a different concept than we talked about in the previous section when we were talking about permutations. So combinations is another way that we can count possibilities. And then we're going to use that to find the probability of an event. So a combination is a selection of objects in which order is not important. Order does not matter. Okay, so order does not matter. Order is not important for combinations. So when we were dealing with permutations, I think we had an example where we talked about picking class president and vice president and secretary and treasurer, and you might have lots of people, maybe let's say you have 30 people, and the order that the students are picked for the positions matters there, because who you pick for president is going to be different than who you pick for vice president or for secretary or for treasurer. So picking Johnny for president and Susie for vice president is very different than picking Susie for president and Johnny for vice president. But here, for combinations, it doesn't matter. So this is like where you would say, I want sausage and pepperoni on my pizza, and somebody else says, I want pepperoni and sausage. It's the same two toppings. It doesn't matter what order they are when you say them. They're still going to put the same two toppings on your pizza. So let's think of this just in terms of four random things here. And we have four letters, A, B, C, and D. And we want to figure out how many ways we can combine these letters into pairs. So we want to put them into groups of two. So if A was my first letter, then I would have to have B, or C, or D. If B was my first letter, then I would have to have A next, or C, or D. So there's three options there. If C was my first letter, then the next one could be A, or B, or D. So there's another three options there. And then if D was my first letter, again, I could have A, or B, or C. But now order doesn't matter. So here I have AB, and then I also have BA. So I don't need to count them twice. So I don't have to worry about BA, because I already have it here with AB. This is like saying I want sausage and pepperoni. This is saying I want pepperoni and sausage. It's the same two toppings on your pizza. Okay? So I have another AC over here when I have CA, and I have another DA over here where I have DAD. So I have AD and DA. So I'm going to cross off those because they repeat. BC is going to be the same as CB. BD is going to be the same as DB. And CD will be the same as DC. So I've eliminated half of my choices there. So now I can count, and I can see there's 1, 2, 3, 4, 5, 6. So there's 6 choices. And how we're going to represent that with a combination notation means that we have 4 letters that we're choosing. So we'll use them in a combination because we're going to put them in a combination of 2 at a time. So that will be our notation that we will be using today, which is right here. So we have a combination of n objects taken r at a time. So here we had 4 letters, and we were putting them in pairs, so we were taking them 2 at a time. So that means, like I wrote up above, we'd have 4C2. So then I would have 4 factorial over 4 minus 2 factorial. So that's the same as a permutation. But then if I multiply it by a 2 factorial, that gets rid of all of my repetition. Okay? So when we work this out, this is really 4 times 3 times 2 times 1 over 4 minus 2 is 2, so that's 2 factorial, 2 times 1, and then I have another 2 factorial, 2 times 1. So the 2 times 1 cancels off, so then I have 12 over 2, which is 6, and that's the answer that I got up above. So again, you can work through this equation by hand, or we can do this on our calculator as well. So I'll show you how to type this into your calculator in class. How you type it into your cell phone or your iPod might be a little bit different. If you have a little graphing calculator, if you have a graphing calculator or a little scientific calculator, there might be different ways to type it in as well. So we'll go over all of those in class to make sure you know how to type it in. But here in example 1, we have a combination of 3 letters. Oh, we're going to count the combinations of 3 letters from the list A, B, C, D, and E. So this time we have 5 letters, and we're going to combine them 3 at a time. So very similar to what I did up above, we'll have 5 factorial over 5 minus 3 factorial times 3 factorial. So again, this first part where we do the 5 factorial and then the 5 minus 3 factorial, that's our permutation. But then this 3 factorial, that gets rid of any repetition. So we'll have 5 times 4 times 3 times 2 times 1. And then 5 minus 3, that is 2. So I'll have 2 factorial, which is 2 times 1. And then I have the 3 factorial, 3 times 2 times 1. So I'm going to chop off the 3 times 2 times 1. And then if you want to cancel the 2 into the 4, you can. Or you can multiply it out and say that you have 20 over 2, which is 10. So our final answer there is 10. So the ways that we could combine the letters A, B, C, D, and E into groups of 3 without having to worry about repetition counted as a different combination, you have 10. You have 10 different ways that you can group those numbers into groups of 3. Okay, so when you're dealing with permutations, you get really big numbers because you have to count every single option. Combinations, our answers are going to be a lot smaller because you're getting rid of all the repetition. Okay, so let's look at example number 2 here. You order a sandwich at a restaurant. So pretend you're going to Subway. You can choose 2 side dishes from the list of 8. How many combinations of side dishes are there? Okay, so maybe you're not at Subway. I don't know if there's side dishes necessarily at Subway, so just pretend you're wherever. But really, we want to order this sandwich with some sides. So maybe at your Panera, that's where you're at. They have sides. So we've got a total of 8, and we're going to combine them 2 at a time. So again, we'll have 8 factorial over, why does it shift like that? Over, we'll do the 8 minus 2 factorial times 2 factorial. So 8 factorial, we're going to write that all out. It's going to take a little bit of time here. And oh, the nice thing is it will cancel. So 8 minus 2, that's going to be 6. So that's 6 factorial. So I'll have 6 times 5 times 4 times 3 times 2 times 1. And then we also have our 2 factorial, another 2 times 1. So I can cancel the 6, 5, 4, 3, 2, 1 with the 6, 5, 4, 3, 2, 1. And then if I multiply across here, I'll have 56, oh my goodness, over 2. And then that will get us 28. So there's 28 different ways that you could pick your side dishes to go with your sandwich. Okay, example 3 here. We have 5 students that are going to be selected from a group of 25 to answer a questionnaire. How many groups of 5 students are possible? So again, we have 25 total students, excuse me, and we're going to combine them 5 at a time. We're going to combine 5 of them together. So I'll have 25 factorial, oh my goodness, over 20 minus 5 factorial times 5 factorial. Now before I write this all out, I want to think, oops, I have one little thing I have to fix here. This isn't 20. That should be 25. I was doing the subtraction in my head while I was thinking. Okay, so we have 25 factorial over 25 minus 5 factorial times 5 factorial. So this 25 minus 5, that's going to end up being 20 factorial. So now, in my numerator, I would have 25 times 24 times 23 times 22 times 21, and so on and so on and so on and so on and so on, all the way down to 1. And then in the denominator, I would also have 20 times 19, 18, 17, 16, 15, and so on and so on and so on, all the way down to 1. And then I would have to cancel. So everything in the numerator from 20 down to 1 is going to cancel with everything here in the 20 factorial, because that's 20 times everything all the way down to 1. So I'm not going to write this all out. I'm going to be smart. I'm going to use a little bit of my brain power to do some cancellation here. I'm going to have the 25, 24, 23, 22, and 21. And then everything from 20 after would cancel with this 20 right here. But I would still have this 5 factorial. 5 times 4 times 3 times 2 times 1. Okay, so now I can cancel some stuff here. The 5, let me switch colors. The 5 will go into the 25 5 times. And the 4 times the 3 times the 2, 4 times 3, that's 12, times 2 is 24. So I can cancel the 4 and the 3 and the 2 with the 24. So now I'll have to just do 5 times 23 times 22 times 21. So my final answer then will be a little bit larger, 53,130 groups. So that's a large number, but again, it's not as big as what the permutation would be because we're getting rid of all the repetition. Okay, example 4 is our last word problem, and then we've got some that we're just going to practice typing into the calculator. So you are ordering a meal from a restaurant. There are 8 choices for your main course and 12 dishes for your side dish. So you can choose 2 main courses and 3 side dishes. How many different meal combinations are possible? So this one's a double combination. So you're going to find all your combinations for the main course and then all your combinations for the side dishes. So it says here that there are 8 choices for your main course, and then you can choose 2 of them. So for our main course, we're going to have 8, and we're going to combine them into groups of 2. And then we're going to multiply that by our other options. There are 12 choices for the side dishes, and we can pick 3. So then we'll have 12, and we're going to combine them into a group of 3. So that will be how I calculate my final answer. So this is where we would want to do this into our calculator, probably. Otherwise, we would have to do 8 factorial over 8 minus 2 factorial times 2 factorial. And then the other one will be 12 factorial over 12 minus 3 factorial times 3 factorial. So if we work this out by hand, it's going to be a little more involved. So remember this 8 minus 2 factorial, that's really 6. So everything from 6, 5, 4, 3, 2, 1, that's all going to cancel. So I'm really just going to have 8 and 7 in the numerator, because the rest of the stuff after that is going to cancel with the 6. And then I still have the 2 and the 1. And actually the 2 will go into the 8 4 times. So 4 times 7, that's going to be 28. And then my other choice here, remember this 12 minus 3, that's a 9 factorial. So everything from 9 to 1 is going to cancel. So I'll still have 12 times 11 times 10, but 9, 8, 7, and so on is going to cancel. And then I still have 3 times 2 times 1. Now 3 times 2 times 1, that's 6. So that'll cancel into the 12 2 times. So now I will have 2 times 10, which is 20, times 11, which is going to be 220. So then if I multiply those two together, then I'll get my final answer here. So I'm really taking the 8 combination 2 and then the 12 combination 3, getting each answer and then multiplying them together to get me the 6,160 ways that I could choose my dinner option. Wow, that's a lot of different meals. But again, not as much as the permutations because we're cutting out all the overlap. So here, if you're choosing a main course, it might be, prime rib or chicken. If you select prime rib and chicken and somebody else selects chicken and prime rib, that's the same thing. It's the same 2 meal options. Okay, so again, we're getting rid of all that overlap here. Okay, so now this last example, this will we'll go over in more detail in class, so that way you know how to type these into each of your calculators. The little scientific calculators have the exclamation point as well as the graphing calculators. You can check on your phone's calculator or your iPods to see if they have this in the app. If they have a scientific mode, they should have it. Okay, so when you evaluate this one, you want to do 10 factorial and probably put it in parentheses, divided by, and then do another parentheses, 6 factorial times 4 factorial. But when you evaluate that, you should get 210. And again, if you want to type it in one big expression, you can, or if you want to do 10 factorial, get an answer, 6 factorial, get an answer, 4 factorial, get an answer, multiply those together, and then divide the 2, that's okay. You can do it in multiple steps. I always say it's better to do it in multiple steps, so that way you make sure you get the answer correct. And for part B, here we've got 14 factorial over 14 minus 2 factorial times 2 factorial. So here, if you're going to type this into your calculator, do the 14 minus 2 first. That's 12 factorial. So simplify that first, so then it looks a little bit more like part A. So again, you can do the 14 factorial, get an answer, take 12 factorial times 2 factorial, get an answer, and then divide the 2, but you should get 91 for your final answer. And then you can also type that in a little bit simpler by using the combination button that's already pre-programmed into your calculator. So in the graphing calculators, this is under the math menu. On the little scientific calculators, I think you have to do second or go into the probability menu to find this. But again, we'll show you that in class. But you would type in the 22 and then hit the combination button and then this 5. And the combination button on your calculator will have the N's and the R's. So you might type 22 and then the little button that has N, C, R, and then 5. Okay, but again, it depends on the type of calculator. But your correct answer here should be 26,334. And again, we'll go over this in class so that way you'll know exactly how to type this in, because if you're doing this for a quiz or a test, I want you to get it correct. And then for part D, here you have 15 items and you're combining them one at a time. Now think about that for a second. You have 15 items and you're choosing one at a time. How many different combinations are there? You should get 15. There's 15 different ways that you can pick 15 things one at a time. Okay? So when you see problems like this, think of what it actually means instead of just going right to your calculator and typing it in. Use a little bit of your brain power there too. So tonight's homework then will be the worksheet 13.3, and it's A, B. It's one side is A and one side is B. And remember that here order does not matter for combinations, and it does matter for permutations. So you get that little sheet in class, the little formula sheet where you get to write down condensed versions of notes and the different formulas. That's a big difference that you want to make sure that you have down on that formula sheet. That permutations, order matters, but not for combinations. Order does not matter for combinations. Okay. So definitely take a look at that worksheet. If you need help with your calculator or the worksheet, let me know, and come on in and see me before school if you have questions.